my name is Bertrand, and welcome to another episode of PowerEdge SoundBytes. Today, I'm going to be talking about functions, also known as serverless. I'm going to be talking about what they are. I'm going to be talking about where they're used, some of their pros and cons, because, obviously, let's face it, nothing's perfect, as well as some of the on-premises offering around function as a service and how you can implement function into your private cloud, into your environment. But let's start with what they are. The term functions was introduced by AWS in 2014 when they released AWS Lambda, which was the first implementation of a function as a service offering. A function is truly a piece of code that gets executed in response to an event. The purpose of a function is to be as small as possible and to only do one thing and one thing well. And that thing gets basically executed when they're triggered by an event. Functions are a higher level of abstraction compared to containers and virtual machines and even bare metal. If we look at the evolution of computing, we're starting way back when with bare metal servers running a single application. And the reason why we moved from bare metal to virtual machine is because when we look at the utilization of those bare metal servers, we figured that we could run multiple applications into a single box. Now, the problem with running multiple applications in a single box without virtual machines is that then you get dependency issues between the applications, whereas a virtual machine encapsulated the entire operating system image and the application that is running on top of it. Now, the downside of a virtual machine is that you basically have an operating system image per virtual machine, which is not a really efficient use of resources. And this is where containers come into play. Because containers, you're basically bundling the application with just what it needs in order to operate, which is obviously a lot more efficient. And a much better use of resources. Functions take that one step further, where they only execute when they need to. So when they're being invoked by an event, they only run for as long as they need to, i.e., they only run for as long as it takes to execute the code that they need to execute. And they also abstract, from a developer's perspective, they also abstract the entire stack. And so the developer only has to focus on building the business logic. Everything down to everything below the runtime and including the runtime is abstracted and is part of the framework. So where are functions used? Functions are typically used in event-driven architecture. And what does that mean? That means that they are part of event processing. So I have an event, and that event does something. I need to process that event and implement some sort of business logic, and that's where the function comes into play. Obviously, a function has to be triggered by an event. That event could be, an HTTP request. It could be a GET request, POST request. It could be a message being put into a message queue. It could be a message as part of a publisher-subscriber pattern. It could be an insertion into Redis. It could be a lot of different things, and different offering will support different events. But the biggest thing to remember is that they are part of an event-driven architecture. So, for instance, let's say I've got a cart microservice. When somebody goes on my website and pick an item and add them to their cart, that creates an event. It's basically I'm adding item ABC of price 1, 2, 3 into my cart. In an event-driven architecture with functions, that event adding the item into my cart will then trigger a function that will process and does whatever it needs to do. It could check inventory, it could make sure the price is right, it would update the database that represents my cart, and could also do other and could also publish messages to other part of the application saying that the cart has been updated. that really is where function comes into, are useful and are typically implemented. Now, what are some of the pros and cons of function? Obviously, the pros is they only run when they need to, and they only run for as long as they need to. So that makes them really, really efficient from a resource perspective and from a resource utilization perspective. Compared to, as I said, compared to virtual machine or virtual machines or containers. The other benefit is that from a developer's perspective, as I mentioned, the only thing I have to worry about is the business logic. I don't have to worry about the plumbing. I don't have to worry about what version of Java, what version of the runtime I have to implement. All of that is provided for me by the framework. Now, the major cons of the major disadvantage of function is what we call the cold startup time. So as I mentioned, functions only run when they need to. But that means that when they're being invoked, they need to effectively start. And that can take some time. Typically cold start for function is anywhere between 2 and 3 seconds, which means that from a latency perspective, if that function hasn't been used for a while, whoever triggers that functions or invoke that function the first time is going to pay a huge penalty, especially for functions that typically run in the milliseconds. And so some of the on-premise offerings are removing that barrier by basically letting the function run all the time, which kind of defies the point a little bit of a function. What are the options if you want to implement a function into your or function as a service framework into your environment, into your private cloud? There are a few open source options. The big 3, I would say, are OpenFAS, Knative, and OpenWhisk. OpenWhisk is an Apache Foundation project that hasn't really been updated in a while, but also that has some significant, is very flexible and is very powerful, but it's also a little bit more complex than the other 2. Knative and OpenFAS are fairly similar, with Knative being very actively developed and is in version 1.40, I think, so fairly mature. And both of them rely on Kubernetes as the backend. So basically what they do is that they implement their function as a pod within Kubernetes. As I mentioned, to avoid cold start time, they give you the option of not scaling down to 0. So scaling down to 0 means that there is no pod implementing that functions that is running. And the benefit of this is that obviously your function truly runs whenever it needs to run. The downside is that you got the cold start. Those options or those offerings allow you to keep one pod running of that functions, which, as I said, can remove the benefit of having functions, function and the transient nature of the function. So functions are not new. As I mentioned, they've been, the first offerings being released in 2014. Some of the on-prem offerings have been released in 2017, 2018, 2019. So they've been around for quite some time. And when we look at microservice architecture, a lot of the microservices, used to be implemented in containers because of the easy nature of containers in terms of deploying new containers and integrating container into your CI/CD pipeline. What we're seeing is that functions are slowly replacing some of those. Where before you would implement a container as a web server to handle some of your, or as an API server, to handle some of your HTTP requests, or as a subscriber in a PubSub pattern. What we're seeing is that some of those are being replaced with FAS, with functions, because of the efficient nature of functions. So this is a quick primer on function. I am planning on writing a blog around function to kind of show how you can implement a function, what does that look like from a coding perspective. And I'm also planning on doing a follow-up interview with Joel Christner, one of our researchers who's actually spent a fair amount of time looking at functions. And I would love to get his thoughts and his view on where they fit and where you see that landscape evolving. So thank you very much for tuning in. Really appreciate your time, and we'll see you in another episode of PowerEdge Soundbite. Thanks a lot.